Diagram below shows a person using a simple machine to move a rock. Well, this is a classic lever. And so if you push down on one side, it pushes the other object up. Levers are interesting though, because you actually have mechanical advantage in effect here. The longer the side that you're pushing down on, the stronger you get. All right. Say if I extended this rod out here like this, and it's now this long, and you were to pull down on it, it wouldn't take you nearly as much effort to lift that rock. You're gaining a superpower basically, but there's always a payoff. The equation for work is work equals force times distance, and you're never going to cheat Mother Nature. With all of these simple machines, you reduce the amount of force. That's true. I'm using less force, but notice to get this rock, say like parallel with the box, I only have to push down like this far right here. Let's call that like a half a meter. And then, whereas with this higher one, I have to push down much farther to get that board level and that rock up, even with the box. And so the distance increases with this. So yes, you are reducing the amount of force, but you're increasing the amount of distance. Like I said, you're not going to rob nature, but that's a fair trade-off. A lot of times we're willing to give up the amount of force, to have to move things a greater distance. The chains on the back door of the school when you go out to the football field, that door is extremely heavy, and it uses a series of pulleys on there. And by adding more and more pulleys, you reduce the amount of force you have to have. But if you've ever seen someone moving that door up by pulling on the chains or running a flag up a flagpole or whatever, they're constantly pulling, and that door just barely moving as it moves up. You're increasing the distance that you're pulling that chain, but you're dramatically reducing the amount of force that you have to have.